Adapt PT2010 Productivity Accelerated. The purpose of this presentation is to show you the expanded modeling, design, and productivity enhancing features of Adapt PT2010. Learn for yourself how this program can accelerate your post-tensioning designs. Adapt PT is the most widely used software worldwide for quick and easy design of post-tension slabs and beam frames. PT2010 includes new design codes such as ACI 318, Hong Kong, and Chinese codes. The program is also now compatible with 32 and 64-bit systems, including XP, Vista, and Windows 7. Several feature improvements and enhancements have been made, including material quantity reporting, moment capacity generation, efficiency in determining crack deflections, file structure format, tendon stress sequence for loss calculations, and many others. Adapt PT 2010 includes use of an input wizard allowing for timely and efficient input of project parameters and criteria. Under general settings, the user can select two-way slab, one-way slab, or beam. For more complex geometries, the user can use segmental construction versus conventional. Also, for beam design, the user can select to use the effective width and bending and whether or not that is considered. Several new codes have been included in Adapt PT 2010, including the Hong Kong code, the Chinese code, and also ACI 318, 2008, and IBC 2009. The user has the option to customize analysis options and also design options in the program. New to design options is generation of moment capacities based on design values or user-entered values. The latter includes the base reinforcement as defined by the user. For span geometries, the user can select up to 20 spans and 2 cantilevers for Adapt PT 2010 Plus, and up to 5 spans and 2 cantilevers for Adapt PT 2010 Standard. Here the geometry of the system is defined. Also, the user has the option to select from several different sections, including rectangular, T-sections, I or L sections, and extended T-sections. Note that the I and L section and the extended T-section are both grayed out. This occurs when the use of effective flange and bending is selected in the previous screen. The user can also select to input segmental construction by changing the prismatic option to non-prismatic, selecting more, and inputting the geometry for the different segments of the certain span. Here we can see in span 3 we've included some segmental geometry. For effective flange width, the user has the option to select the calculation based on ACI 318 or on user-defined input. Support geometries and stiffness can be considered in the program. We can select lower column, both columns, lower and upper, and also no columns where a pin support will be assumed. If we select both columns, we can input the height of the column, we can input the dimensions of the column, and also we can include a percentage of column stiffness to be considered in the analysis. This can be done for both the upper and also the lower columns. The support width for reduction of moments can be selected. If we want to use the support width based on the column dimensions, we can check this box under support width. If we would like to input user-defined support widths, we unselect the box, and here we can write in the value. Also, the boundary conditions for columns can be input for the lower column and the upper column, both near and far on the column. We have the option to select fixed, pinned, or a roller condition. Several different load types can be input for use on the system, including uniform, partial uniform, concentrated, and many others. We can also define the class of load, including superimposed dead load, live load, or also X load. This can be done for any span in the system. We can also include to skip the live load with a skip factor, and whether or not to include the self-weight with a specified unit weight. Material input can then be defined for both concrete, reinforcement, and also for post-tensioning. If we go back to concrete, we can see we can input material definitions and material properties for the slab and the beam and also the column. Note that for slab and beam we can input the creep coefficient to be used in long-term deflection calculations. Material reinforcement can be defined as well as the preferred bar size for the top bars and also the bottom bars. Also, shear reinforcement preferred size can be defined, and the number of legs can be defined for the analysis. Post-tension settings include the preferred system, bonded or unbonded, the area of the strand, this can include one strand or more than one strand, the ultimate strength of the strand, and also the long-term effective stress to be used for force selection method. The user has the option to define base reinforcement in the system. If no base reinforcement is defined, the program will design all reinforcement necessary to supplement the post-tensioning for serviceability and strength requirements. The user can select Yes to define base reinforcement. For this force band plus one cantilever condition, we've included base reinforcement for the top and the bottom. This includes 2 number 5s in the top and 2 number 5s in the bottom. Note that this is a function of the span length. The first end location is span 1, where we have a 0 as the x over L ratio, and the second end location is the cantilever right, where we have 1 as the x over L ratio. This includes rebar continuous across all 4 spans and into the end of the cantilever for the top and the bottom. The allowable stresses can be defined for tension and compression by the user for sustained, total, and initial stress. For this particular system, we've defined 7.5 times square root f prime c for the sustained and the total tensile stress. The user can also define the average precompression and the percentage of dead load to balance as a range of minimum to maximum. The program will use these values in determining the required PT force in the recycler screen. The analysis and design method can be either the calculated force method or the force selection method. If we use force selection method, the program will base the minimum long-term force from the long-term effective stress as defined in a previous input screen. If we use calculated force method, the user will input certain parameters for friction stress loss and also for long-term stress loss. Note also that you can select No for long-term stress loss and include a lump sum value for the long-term stress. We'll include a long-term stress loss estimate of 15,000 psi. The tendon profiles can be defined for each span. These include a reverse parabola, a partial parabola, harped parabola, a straight segment, or extended reverse parabola. The inflection points for each span can be defined in the table below, and these profiles can be selected for tendon A, B, and also tendon C. The cover and the CGS of tendons can be defined in the next section. Here we can define the minimum CGS of tendon from the top and bottom fiber, and also the non-pre-stressed reinforcement clear cover for the top and the bottom. Note that this clear cover is from the top fiber or the bottom fiber to the longitudinal steel. We can also include the minimum bar lengths for serviceability rebar, and also the development length of required rebar for strength. These include bar extensions as defined by the user. The user has the option to select 4 strength combinations and 4 service combinations, including 1 load combination for the initial condition. You can also select lateral load combinations by selecting set values. Here we can input the moments, lateral moments, at the left span and the right span, and we can also include the lateral load combinations with a selection up to 2. We can reverse the sign of the moment, and we can also include the percentage of the PT to resist factored moment for lateral moments. Once we've defined all of the input, we would save the file. Under File, Save or Save As, and then we can run the analysis. Once the analysis has been completed, the PT recycling screen will appear. The user then has the option to review results for the analysis. This screen contains several tabs with results. The first, tendon force and height, allow the user to review results such as the PT force selected, the precompression, the percent dead load balanced, tendon control points, this is for the current tendon, and the same results appear for all tendons, the sum of tendons A, tendon B, and tendon C. Notice in this design we have selected tendon A and also tendon C, which is included in the cantilever right. We can also review the required and provided PT forces. On the left we see required PT forces, and on the right provided PT forces at the left, center, and right for each span. We can also review the required PT force based on tensile stress, precompression, and balance load percentage. The extreme fiber stresses are shown in tab 4. We can view the stresses for sustained load condition, total load condition, and also the initial load condition. Note that both the tension and the compression stresses are shown for left, center, and right, and also the allowable or suggested stresses are shown to the right. During the input of the design, we selected tendon selection method. If we go to tab 5, we can see we have one tendon, tendon A, which has a dead end on the left side and a live end on the right. We've also added tendon C, which is pulled just from the left of support 5 towards the right through the cantilever. We've selected 20 strands for tendon A and 1 strand for tendon C. These are anchored at the centroid for the add tendons. Once the design has been completed and reviewed in the recycling screen, we can go ahead and press exit, and the rest of the design and analysis will take place. A message will now appear saying that the execution has been successfully completed. There are also several warnings showing what each tab represents in the top left of the screen. To view graphical output, we'll select this option. Several different graphs will appear, including the tendon height diagram with the concrete outline, the post-tensioning required versus provided for each 20th point along each span, a stress diagram output, which allows the user to show stresses for top fiber and bottom fiber for the sustained, total, and initial condition. If we select bottom fiber for total condition, we see a gray envelope which includes the allowable stress diagram. The green represents tensile stresses, and the blue represents compressive stresses. The deflection diagrams are set by default to service envelope condition. We can also review deflections for each individual load case, including self-weight, live load, post-tensioning, superimposed dead load, X-load or other loading, and we can also user define the load. If we set values, we can select different load factors for each load case for a combined result for deflection. We can also review shears for strength, service, and each individual load case, and the same for moments. The user can also go back and edit input from the Edit Input tab, rerun the analysis, go back to a previously saved design, generate a report from Report Generator, or review results for load combinations using the Builder Sum tab. If we open Builder Sum, we again see a message screen which identifies each of the tabs to the top left. We can select any load combination, including the envelope. Here we can select shear and axial force results, moment results, stress results, reinforcing results, and finally we can generate a summary report for the selected load combination. The summary report contains information like top rebar, tendon profile including control points and forces per span, bottom reinforcing, required and provided longitudinal reinforcing including decimal format values for maximum, of the top and bottom reinforcing, shear stirrups, and design parameters. Note that all results, both graphical and in design summary, can be exported and printed using the options to the top left of the screen under Graphs or using this icon here. Once the results have been reviewed in Builder Sum, we can close this module, and finally we can select the report generator to begin in preparing reports. Customized or full reports can be created from the report generator. To create a full report, we would make a selection for each of the boxes on the left-hand side. Once made, we can say Create New Report, and a Word document would appear. To customize a report, we can select any of these options or expand the options for concise, tabular compact, tabular detailed, or graphical reports. For example, if we want to select under Detailed Reports the demand moment and moment capacity, we would make selection for number 34. And also, under Concise Reports, if we want to report the material quantities, we would make a selection for B.9 under Concise Report. Both of these options are new to PT2010. Once the reports have been selected, we'll say Create New Report, we'll name the report, and save. A Word document will appear showing the saved and created reports. Here we have material quantities for concrete, mild steel, and pre-stressing, and also the demand moment and moment capacities for both positive and negative moments, including the demand capacity ratio. This occurs for each span at each design section. Similar reports can be created in this manner. This will conclude the demo of ADAPT PT 2010, Productivity Accelerated.